For section 6 of chapter 6, we're going to talk about how to graph systems of inequalities. Now, you've done a lot of practice in the past with graphing these individually. So at the very end of chapter 5, we talked about graphing an inequality line, and we had to go over those rules of whether it's a solid line or a dotted line. So you'll have to remember that if it doesn't have an equal sign, that means that you need to have a dotted line. And then we also talked about testing a point. And a lot of times we did 0, 0 in order for us to shade on the correct side of the lines. Now we're going to do some of that again today, but we're talking about these systems. So just like you've seen all chapter long, you're going to have two separate equations given to you with both x and y. And we're going to want to graph both of them, both of the lines that they give us, and then shade on the correct side of both lines. And what we're going to be looking for is where does the shading overlap, because that's going to be the solution set for both of the equations that we're looking at in our system. So our steps that we're going to follow are to graph each inequality separately and to shade differently from each other. And then the solution is going to be the area where everything overlaps, and it's going to be what they have in common. Now, when you guys are doing this on your own, you may want to use different colors to do like your different shading, or just make sure that you can understand that you're looking for where they're going to overlap. So you don't want to shade too darkly in one area, because then you might not be able to see the shading in a different area as well. So let's take a look at this first example here that I have together. Now I've got two equations. The first one says y is greater than or equal to 5, and the other one says x plus y is less than 3. Now I'm going to go ahead and graph the first line. So let's get our coordinate plane drawn in up here. So this first one, this x is greater than or equal to 5. So that has no y value. So remember in the past when we've seen lines like this, when it doesn't have a y value, that means that it can't cross the y-axis. So your y-axis is that line on the coordinate plane that goes up and down. So we want to go over to positive 5 on the x-axis. That would be going over to the right 5 spaces. So you're sitting like right there, and we're going to draw a line through that point going up and down. So it's going to be parallel to that y-axis. Now if you look at your inequality sign, this one says greater than or equal to. So if you remember from our rules in chapter 5, that means that you're going to have a solid line. So up and down through this point, we're going to draw a straight solid line here. Now, if we think about what side of the line we want to shade on, this says that x needs to be greater than or equal to 5. So think about 5 on the x-axis there, and think about that x-axis like a number line. What side would be bigger than 5? The left or the right? Well, anything to the right is going to be numbers that are bigger than 5, because that would be like 6 and 7 and 8 and 9 and so on. So for that first line, we're going to shade over here. Now this is what you guys did in chapter 5, and you would have stopped here, because they would have only given you one line to graph and having to do your shading. But we've got a second equation here. Now if you look at this one, do you guys think that that's ready to graph? Hopefully you said no, or you're thinking no, because y is not by itself. And anytime that we've graphed lines in this chapter or in the previous chapters, we've talked about how you have to have it in that slope-intercept form, that y equals mx plus b. And this one is not quite there. We have x plus y is less than 3. So how would we get y by itself? Well, we're going to subtract that x over to the other side. So I'm going to write minus x on both sides here. So we're going to have y is less than, remember we always put the x first because we want it in this form, so we want it to match. So it's going to be negative x plus 3. Now we're able to graph this line. So what I'm going to do is I'm going to start using the b, so that's that plus 3. So I'm going to go up 3 on my y-axis here. So starting from 0, 0, you're going to go up 1, 2, 3, and draw your first point. Okay, so you guys take a look at this equation. What's the slope of this line? Remember, the slope comes from in front of your x. And the x has a negative in front of it. So it's technically like a negative 1. And if we think about rise over run, we can put that over 1 as well. So it's negative 1 over 1. So from 3, from that first point, we are going to go down 1 and right 1. Make sure when you guys are doing this, so you're only going negative in one direction. So since you're going down, that's the negative 1. And then you're going to go over positive 1. Okay, now if you look at the inequality sign for this one, it just says less than. There is no equal sign with this one. So when you guys draw your line in here, it has to be a dashed line. Now, these are going to overlap, and that's okay. What we want to do now is figure out where do we shade. Okay, now in the past, we've talked about how you guys can test points. So if you really wanted to, you could put in 0, 0 for your x and for your y. 0, 0 again is a good point because it doesn't go, it's not on that graph, it's that origin. 0 is easy to operate with. So if you put a 0 in for y and a 0 in for your x, you'd have like negative 0 plus 3. You're going to be left with this. 0 is less than 3, which is going to be true. Now, some of you may start to understand that that inequality sign also kind of tells you like where you should shade. So remember when I did my first line, I said that I needed points that were greater than or equal to 5, and that was everything on the right-hand side of the line, okay, because that's bigger. Now, if you guys can understand and think about, if I'm looking at this orange dotted line here, and I want everything less than means the same thing like underneath the graph, which when you tested 0, 0, you found that this was true. So that means that we want to include 0, 0 in our shading. So it does make sense that I would shade down here. I would include 0, 0 in on that. Now, keep shading and shade enough so that you can see where your colors are going to overlap. Okay, mine overlap just in this area right here. Kind of where I'm coming in. And I'm just going to darken that up. So you can kind of see where those colors are mixing down there. When you guys are doing this on your own, if you want to highlight the area that they overlap so I can see your solution set, that's fine. Or if you just want to use a pencil, that's good too. Just darken that space up. So I want you guys to kind of color in that little corner there. Now remember, these lines keep going forever in both directions. So eventually this is going to widen out some more. We're just not seeing it right now because I've got limited space here for my graph. But eventually it's going to widen out some. And so you're going to have more space that's going to end up getting shaded together. But right now we just kind of see this area right here in between those lines. Okay, so that's basically what we're going to be doing today. You're going to be graphing 2 separate lines, shading 2 separate times, and you're going to be looking for where they overlap. So I'm going to scroll down to this next example here. And I want you guys to try to do this problem. So at this point, you may need to pause the video so you can give yourself some time to think through this problem. And then when you're ready to see the solution, go ahead and resume watching. All right, the nice thing about this one is that both of these equations are already written in slope-intercept form for you. You don't have to do any rewriting at all. They both have that y equals mx plus b form. So let's go ahead and start graphing. So starting with that first one, y is greater than or equal to 2x minus 2. You should have started down at negative 2, which means from 0, 0, you go down 2 spaces. Draw your first point. Your slope for that line, it says 2x. So 2, think of it as 2 over 1 would be your slope. So you're going to go up 2 and right 1. And remember, you guys can draw as many points as you want here. You need at least 2. but you can always do more if you want to see where your line goes. And then again, I would still encourage you guys to be using lunch cards or something like that as a straight edge, so your lines are nice and flat and straight. They're not squiggly or crooked. And what you're going to do now is connect. Now you should have had a solid line for this one because there's that equal sign in the inequality. Now for this first one, if you can understand how to shade based off of the inequality sign, great. If you needed to test a point, you could have still tested 0, 0 in that first equation there. If I put a 0 in for y, it would say 0 is greater than or equal to. If I put a 0 in for x, you would have 2 times 0, which is 0, minus 2. You'd be left with 0 is greater than or equal to negative 2, which is true. 0 is bigger than anything that's negative, so I'm going to want to include 0, 0. So I would have shaded on this side of the line. This is what would be greater than the line because it's above that line. Now, moving on to the second equation. It says y is less than negative x plus 2. So what you should have done is started up at positive 2 this time. So go up 2 and draw your first point. And your slope for this one, just like in that example I showed you up above, it's negative x, which means that your slope is down 1 and right 1. This one, if you look at the inequality sign, does not have an equal sign, so we have to make sure that we have a dashed or dotted line through all those points. And now let's shade. Now this again, it says less than. So if you can understand, that means that we're going to shade underneath the line. You can go ahead and do that. If you need to still put 0, 0 in, because that's still an okay point for me to test, I would have 0 in for y, less than, you'd have negative 0, which doesn't matter, plus 2. So you'd have 0 is less than 2, which is also true. So it makes sense again why we're going to shade underneath the line here. Okay, now this one, look at where they overlap. On this side of the graph. So I'm kind of coming in with my purple color here, and they're going to kind of start to mix a little bit. So you should have darkened up this space on your graph to kind of show that this is where they're going to overlap. All right, let's go ahead and look at the next page. So if you look at these two examples, once again, they're already written in slope-intercept form for us. Okay, they have that y equals mx plus b form, so I don't have to worry about rewriting any of these, which is nice. Now, if you guys take a minute, look at these two equations. Do you notice anything about them that are the same? Some of you may have noticed that if you look, they both have this 2x. So that's the slope. So both of these lines have a slope of 2. What does that mean? What type of lines are we looking at here? Hopefully you're thinking this means we have parallel lines. So you should know, going forward, that when I go to graph these two lines, they're never going to cross. Now that doesn't necessarily mean that there's not going to be a solution here, because we are still going to have to talk about shading, and we're going to have to see if they have anything in common as far as shading goes. So we may still get a no solution, or they may overlap in the same spot, and then they're going to have all that area or all that space that's shaded in shared. So let's see what happens with this one. Starting with that first line, we're going to go up 3 and draw our first point. Now that slope that I circled there, that 2x, remember that's like 2 over a 1. So you're going to go up 2 and right 1, up 2 and right 1. Now if you want to add more points and you're running out of space on your graph like I am here, instead you can always go down 2 and left 1. Remember, you guys can go the opposite direction if you're running out of room. Should I have a solid line or a dashed line for this one? Should be a dashed line. So I'm going to go ahead and draw that in. Again, a dashed line because there's no equal sign. Now, shading, you can still test your point 0, 0. If you guys are comfortable with doing that, I would keep testing that point from this point on here. Or you can understand that that sign says greater than, so you're going to shade above the line. But so you're going to go 0 in for y, greater than 2 times 0 is 0, plus 3. 0 greater than 3 would be false. Okay, so I do not want to include 0, 0, the origin, and that's why I said you're going to shade above the line, which would be over here. This would be above the line. So that's for your first one. Now let's graph the second line. So we start down at -1. So from 0, 0, you go down 1. And then your slope is that 2 over 1 again. So it's going to have the same slope. That's because we said that these lines are parallel. So I'm going to go up 2 and over 1 again. This one is also going to be dotted, a dashed line, because there's no equal sign. Okay, so we're seeing our parallel lines here, but now what we need to figure out is what side of the line we shade on for this one. So it is possible that if we have to shade over here, that they're going to overlap, right? But if I don't shade over here and I have to shade over here, then they're not going to overlap. So let's figure out which side we have to shade on. So again, if you want to put in 0, 0, 0 goes in for y, less than 2 times 0 in for x would be 0, minus 1 would be -1. 0 is less than -1. That's false. So I don't want to include 0, 0 on the green line either. So 0, 0 would be over here. So I want to shade on the other side. So you will shade off to the right. So when you look at this one, they don't overlap. The only space that they could overlap is if one of these had started to shade like in the middle of these lines and then went over to the other side. So they don't share anything for this one. So for this one, we are still going to say that there's no solution because they don't share any of that shaded region. Now, not all of them will be no solution. You might see some where you shade over here, and then they would have overlapped, and so that would be their common area of solutions there is when they cross. But this one didn't work out that way, so we're still going to say no solution. Now I want you guys to practice this. So I have a practice problem underneath on this page. Okay, you're dealing with a similar situation in that you've got these two lines, and look at them. They're already ready to go for you to graph. And once again, if you look at your slopes. They're the same. So you're going to deal with those parallel lines again. So what I want you guys to do is take a minute, pause the video here, graph these lines, figure out where you're going to shade, and then when you're ready to see what it should have looked like, go ahead and continue watching. Alright, I'm going to draw my coordinate plane in here, and then we're going to run through the graphs. So for the first one, you start down at -4. So down 1, 2, 3, 4. Now my slope is -3 over 1. I don't have space to go down 3 on my graph here. Whoops. So I'm going to go up 3 and left 1. Because left would be negative now. And then I'm going to go up 3 again and left 1 another time. So I can start to see that line. Remember, these are negative lines, so they should be going down over time. Dotted line because there's no equal sign. Okay, to shade on this one, if you put 0, 0 in, you should have been left with 0 is greater than -4, which is true. So we're going to shade over on this side of the line because I want to include 0, 0. For the second equation, we start up at +2. Same slope. So I'm going down 3, right 1. Or up 3, left 1. Still a dotted line because it still doesn't have an equal sign in that inequality. Once again, we've got those parallel lines here. If I put 0, 0 in for my values for x and y, I would be left with 0 is less than 2. Which is true. So again, on the green line, I want to include the origin. So I shade on this side. And hopefully you guys notice that they overlap in between. So I'm just going to go in between those dotted lines and just kind of darken that space up here. Just kind of color that in a little bit more. And that's where the solution set's going to be. So this is slightly different than that last one because they actually do share some solutions on this graph. It's not a no solution situation where they're shading in opposite directions. So this one is similar in that they were still parallel lines. However, we are able to see that they do have an overlap, so they do have some solutions in common. All right, if we turn the page here, let's take a look at this next example. This is similar to what we started with in that we are given two equations. Unfortunately, though, we're going to have to rewrite both of them because neither of them are ready for us to graph. So you're not going to do anything different as far as the graphing stuff goes. The piece that's going to be different here is that you're going to have to do a little bit of work before you can graph those. So let's go ahead and walk through and rewrite both of these equations. We'll start with the first one here. Negative x minus y is less than negative 2. I want to get y alone. So let's move that negative x over first. Since it's negative, we're going to add x over. So it's going to say negative y is less than, x goes first, so it's positive x now, minus 2. Remember, we can't leave y negative, so we got to get that negative sign away from it. So what we're going to do is divide everything by a negative 1. When you guys divided or you multiplied by a negative, do you remember what happened to your inequality sign? You have to make sure that you flip it. So this is going to say y. This inequality sign is going to flip, so now it says greater than, and then we're going to switch the signs of these two terms over here. So now x is going to be negative again, and that negative 2 is going to become positive 2. So this will be the first line that we graph. Okay, so how about you guys take a minute and you rewrite that second equation. All right, what I would have done first is added 4x over. So we have 2y less than or equal to 4x plus 8. Then we're going to divide everything by 2. Now this time you're dividing by a positive, so you do not need to switch your sign. So it's going to be y is less than or equal to, and then this is going to become 2x plus 4. Okay, now let's graph it. Starting with this one over here, y is greater than negative x plus 2. You need to start at 2, so you're going to go up 2 from your origin. And then your slope is negative 1, so you're going to go down 1, right 1. Down 1, right 1. Dotted line because there's no equal sign with that inequality. Okay, if we test 0, 0, you put 0 in for y, 0 in for x, you're going to be left with 0 is greater than 2, which is false. So we do not want to include 0, 0, which means I'm going to shade on the other side. over here. Away from 0, 0. Now for your second line, you're going to start up at positive 4. Your slope is 2 over 1, so you're going to go up 2 and over 1. Or you could always go down 2 and left 1 if you're running out of space, or you want to get some more points on this other side. Now this one is going to be solid. It's going to be a solid line because we do have an equal sign here. So solid line. Now let's put 0 in for x and in for y. So we'd have 0 less than or equal to 2 times 0, which is 0, plus 4. So 0 is less than or equal to 4, which is true. So for the green line, I do want to include 0, 0, so I'm going to shade over here. And then once again, look for where your guys' shading overlapped. It should be up in this area here. So just darken that in. There's one more practice problem. Go ahead and, again, pause the video, work this one out, rewrite both of those equations, graph them, see what happens, and when you're ready to see the solution, go ahead and resume watching. All right, so let's start by rewriting both of these. Okay, so there's your first one. Now the second one. Just like on that practice problem, you got to divide by that -1, so you are going to end up switching your sign. So it's going to say y is less than or equal to positive 4x now minus 1, and we're going to graph this line as well. Now some of you may have noticed when you got those two lines that they have the same slope. So that is going to be one of those situations again where we have these parallel lines. Now for this first one, you got to go all the way up to 13. So I might need to redraw my graph here so we got space to go up to 13. I'm just going to lower that a little bit. So we're going to go up to 13. Now my slope is 4 over 1. I don't have space to go up 4 and right 1, so instead I'm going to go down 4, left 1. Okay, should be a dotted line because there's no equal sign. Okay, and then you needed to shade. If you put 0, 0 in, you should have been left with 0 is greater than 13, which would be false. So I do not want to include 0, 0, so I shaded on kind of the left side of that line. For your second equation, you start down at -1, and then your slope is still 4 over 1. So now I'm able to go up 4 and right 1 because I've got space. This line should have been solid because it has an equal sign. Then again, I'm going to put 0, 0 in, so 0 in for y, less than or equal to, this would end up being -1. 0 is less than or equal to -1, that's also false. So I do not want to include 0, 0, which is right there, so I want to go on the other side of that green line. So when I looked at this one, they don't overlap, so this has no solution to it.